Hey everyone, and welcome back. Today we're diving into an absolutely fascinating topic. We are exploring the exact title of our explainer, Natural Interaction Application Task Video Overview. Okay, let's just get right into this because we interact with artificial intelligence literally every single day. We talk to our phones, we upload pictures, we type out these long questions, and honestly, because the responses we get back feel so incredibly human, it's really easy to forget what's actually happening behind the screen. So today, we're going to strip away the magic. We're going to look at the cold, hard facts of exactly how these inputs are represented and processed, and we'll prove why a natural-looking response is absolutely not proof of human understanding. To do this, we've got a 4-step investigation plan for today. First up, Phase 1, the illusion of understanding. Then, Phase 2, behind the curtain. Next is Phase 3, the investigator's lab. And finally, Phase 4, the curveball.
All right, let's kick things off right now with Phase 1, the illusion of understanding.
So this is where we need to confront probably the biggest misconception in the world of AI right now. Think about the human experience for a second. When you and I have a conversation, you hear my voice, right? You interpret my tone, you draw on your own life experiences, and you truly understand the meaning behind my words. That is human cognition. But then you have the AI reality. When you speak to an AI, it isn't hearing you. Actually, scratch that. It doesn't have ears or empathy at all. It's just processing audio sensor data and calculating statistical patterns. The trap we all fall into is believing that just because an AI processes our natural language so fluently or recognizes an image perfectly, it must somehow possess human-like understanding. But you've got to remember this golden rule. A fluent, grammatically perfect, and totally contextually appropriate response from an AI is never, ever proof of comprehension. It is simply proof of incredibly complex math.
And that brings us right into Phase 2, behind the curtain.
So, if the AI doesn't actually understand us, how on earth is it pulling off such a convincing trick? Well, to find out, we're going to use a framework directly from the OECD to trace a single natural interaction from start to finish. According to this framework, an AI system relies on 3 core elements to interact with the world. And a quick heads up, we have to be super careful not to humanize these steps. Step 1 is sensors. The machine doesn't see or hear, rather its sensors, like a microphone or a camera lens, just collect raw data inputs from the environment. Sound waves become digital frequencies, light becomes pixels. Then step 2 is operational logic. The machine isn't thinking about what you said. Instead, its operational logic steps in to interpret that data based on a specific set of objectives. It's literally just looking for patterns. And finally, step 3, actuators. The machine doesn't decide to reply to you. The actuators take the output of that logic and produce a response to change the environment. Think of text popping up on a screen or a synthesized voice coming out of a speaker. It's just raw data in, pattern processing, raw data out.
To put that into perspective, in modern AI, we are primarily dealing with what's called statistical AI, or machine learning. This basically means machines deduce a trend from a massive set of patterns through trial and error. They absolutely do not use human logical deduction. Like, they don't actually know that a dog is a living, breathing animal with a wet nose. They just know that a very specific arrangement of pixels frequently correlates with the label dog. The system builds a natural-looking response entirely through mathematical pattern matching. There is not a single shred of actual conscious understanding taking place there. Okay, let's put this into practice. Welcome to Phase 3, the investigator's lab. Now that we've mapped out the reality of how this works, it's time to apply it. We're going to perform a claim, evidence, and reasoning task on a brand new interaction. Imagine you ask an AI a question using your voice. Let's break it down. First up, the input data. The evidence here is just the raw voice audio collected by the microphone sensors. Next, the operational logic model. The AI utilizes statistical matching to map those incoming sound waves to text patterns. Then we get to the output. The actuator generates a text response or a synthesized voice right back to you. But, and this is a big but, here's where we have to apply our critical reasoning. We have to look at the uncertainty and risk. Because this entire thing relies solely on statistics, there's a massive risk of the AI misinterpreting an accent, background noise, or a cultural context. It doesn't know you're being sarcastic. Therefore, the final step is absolutely non-negotiable: the human check. A human must always evaluate the output for accuracy and truthfulness. And you know, this need for human check isn't just my personal opinion. It's a foundational pillar of responsible technology use.
As this quote from the NIST AI Risk Management Framework explicitly states, we have to manage risks to individuals, organizations, and society associated with artificial intelligence to improve the ability to incorporate trustworthiness. Because AI relies on statistical probabilities rather than human reasoning, a fluent response is never automatically a correct response. Human oversight is literally the only mechanism we have to manage that risk and ensure these systems are actually trustworthy.
Which leads us perfectly into our final test for today. Phase 4, the curveball. So we know how the system works under ideal conditions, right? But let's be real, the real world is rarely ideal. It is time for a transfer check. What happens if the input data changes or degrades? Imagine you're standing in a super crowded, noisy subway station trying to use a voice assistant. Or say you're feeding an image recognition AI a photo that is incredibly blurry and poorly lit. If the AI truly possessed human understanding, it could probably just use common sense to fill in the blanks, exactly like you or I would. But let's see what actually happens.
Honestly, this brilliantly illustrates the limitations of the technology. When the environment gets messy, the entire interaction fundamentally breaks down. First, the sensors collect degraded raw data. It's just a jumble of noise or a bunch of blurry pixels. Second, because that data is totally outside the norm of its training, the operational logic completely fails to match it to any statistical patterns. It can't just guess based on life experience like we do. And third, the actuators are forced to produce unpredictable, nonsensical, or entirely incorrect outputs. Ultimately, altering the input quality proves, beyond a shadow of a doubt, that the AI relies strictly on mathematical representation. It proves a complete lack of true comprehension. Without us humans there to contextualize the noise, the whole illusion just shatters entirely.
As we wrap up our investigation today, I want to leave you all with a vital responsibility. Every single time you interact with an AI, whether you're chatting via text, speaking to a voice assistant, or having it process an image for you, I want you to remember the mechanics behind the curtain. The fluency of the output is a mathematical achievement. It is not a cognitive one. We've got to maintain a healthy skepticism, verify those outputs, and remember that human oversight is the irreplaceable final step in any AI interaction. Think about it. If a machine can mimic understanding this fluently today based purely on math, how are we going to learn to distinguish between genuine human connection and statistical probability tomorrow? Keep questioning everything and definitely keep verifying. Thank you so much for joining me for Unit 02, Lesson 05, Natural Interaction Application Task Video Overview.